Professor Prabhat Verma Sir, Professor in the Department of Computer Science and Engineering at NVTU Kanpur, with over 25 years of academic experience, Sir has made significant contribution to teaching and research in computer science. He was honored with the UPCST Research Fellowship for his effort in promoting science and technology. His research interest includes human-computer interaction, artificial intelligence, and object-oriented software engineering. He has published over 35 research papers in reputed journals. It gives us joy to have him with us today, and now we look forward to learn from his expertise. Now, I would like to call Professor Prabhat Verma Sir. Sir, can we start the session?
Yes, thank you, Neha ma'am.
Thank you, sir.
First of all, I would like to thank organizers for inviting me, especially Dr. Vibhash Yadav, convener, for inviting me for this lecture. And I hope that this lecture will be beneficial for all of you. So I will share my experiences with all of you. So I am going to present it. So is my screen visible?
Yes sir,
Yes, sir.
visible है. Full screen कर लीजिए सर. Yes sir, it's okay now.
So the topic is modeling sequential data, RNN, LSTM, and LLM. So basically, these all deals with deep learning. So we shall discuss here from the scratch or from the basics, so that those who are in the process of learning, they would be able to understand easily. We begin with a small example for understanding the importance of the sequential modeling or the sequential data. Suppose you are given an image of a ball. Can we predict where it will go next in two-dimensional? Here only the ball is given and we have to predict that where it will go next. So our prediction will be random only because we don't have any prior knowledge of the ball where it was earlier. So we can give a random guess only. But in the other hand, if you are given its prior information that where it was few seconds back, then our problem becomes much easier. We can predict it to much certainty that what will be its next position. So this is the importance of sequence. Sequence in modeling, when their time is involved, when sequence is involved in the form of the various events. There are so many real life examples where sequence does plays, like audio, our speech, for example. Right, speech is also a sequential signal or time dependent signal, where the precedence is important in the form of the speech signal. Similarly, we can say sequence is there in any text, like sequence in characters, sequence in words, sequence in sentences. So sequence does play a very important role. Similarly, take example of stock market. In stock market, there is, you can say, the the various parameters or the various values of the stocks, they may rise or fall during the day. So there is a sort of sequence or temporal data. This is also called the temporal data. You take an example of the genetic or the DNA sequencing. There is a sort of sequence of characters, which is that sequence is important to understand the features of that particular genome. Similarly, say the ECG signals. So there also the sequence is there that is important. So these all are the time dependent signals. So we have to model these. Similarly, say a video. A video is made up of so many sequential images or the photographs, right? So there is a sequence. If a person is walking or running, there is a sequence in his running. Okay. Earth is revolving, so there is a sequence. Okay, or Earth is rotating or revolving, so there is a sequence. So sequence does play very important role in our day-to-day life. Okay, so there are so many applications that are based on the sequence. We can categorize them in on the basis of the cardinality. Like in the binary classification, there is one-to-one correspondence between input and output. Like on the left side, we can say that there is one input and one output. That we can say it is a binary classification. For example, there is a simple question: will I pass this class? So there is a student and there is a target value, that is whether he's pass or fail. So that is one-to-one type of application. There may be many to one type of application, like in case of the sentiment classification in a sentence or a tweet. See the second diagram, where there are so many inputs in the form of the words, sequential words in the sentence, and we are processing those words through a model, and it is giving a single targeted output with what is the sentiment of that particular tweet or the sentence. So this is an example of many to one type of sentiment classification. There can be one to many classification examples also. Like for example, you are given an image and you have to make the caption of the image. What does this image say in the form of a sentence? So you are having only single image, so single input, and the output targeted variables are many in the form of the words. So this is another category of the modeling where we talk of the one-to-many type of capturing. There may be another class where we can how to deal with the many-to-many, many input and many output. For example, in case of the machine translation from one language to other language. Okay, so we are having so many words in that source language and corresponding words in the targeted language we have to find out by the model or predict through the model. So we can have that so many applications are there which belong to the sequence modeling. So in nutshell, we can say that we are having to deal with so many times the data which is temporal, which is time dependent. So in that case, we have to deal with the sequential modeling. So when we talk about modeling for sequences, there are so many models that we shall discuss. Like to begin with, you are having one model that is known as the HMM, Hidden Markov model. Right. So hidden Markov model is based on the probability theory. So basically it deals using the transition probability, and with the help of the hidden Markov model, you can predict or you can learn a system as well. But the drawbacks of HMM are that it is suitable for only the limited domain. When the domain size is very limited, then only it is suitable. As the size of the domain grows, it becomes a fail to predict correctly. So that is a model that is suitable for a small domain size, uh, and it makes use of the probability theory. The other model that we shall be discussing, they are based on the neural network models, especially the deep learning models. Okay, so that are more robust and more complex, and they are very successful models that we shall be discussing with. So they are based on the deep learning. So when you talk about the deep learning, you might have heard two terms very frequently: CNN and RNN. Right, CNN is convolution neural network, and RNN is recurring neural network, recurrent neural network. So when we talk about the CNN deals with the image data basically, and you when you talk about the CNN is basically deal with a single instance of time. It is not useful for the sequence of the data that is sequential in nature. Like for example, when you want to make a model for emotion recognition of a person, right? Then you would be using the images, various images from the data set, and you will be creating a model. So that particular model is based on the CNN that takes only single instance of time. That takes only single instance of time, not multiple instances of time. So CNN is based on a single instance of time. But on the other hand, when you are having the problem requirement such that you are having the history data also, which is responsible for the present situation or the next outcome, then you have to deal with the sequential data. And here the RNN is better performing, which is a recurrent neural network. So RNN would be useful, which is temporal, which is time dependent, or the sequence dependent, which is modeled over the sequential data. So RNN we shall discuss with here from the beginning. So to begin with, neurons. You are familiar with the neural networks. So this is the you can say the beginning of the neural network, like perceptron. Perceptron was a single neuron, very simple neural network, which takes some input parameters and converts it into some prediction, whether it is a classification. Right. So here you are having input parameters. You apply some weights over it. Then you are having this neuron. Here on the neuron, these combined weights with the parameters are fed to the neuron, and the neuron transforms this input data through this some function, which is known as the activation function. We call it as activation function. So by this, it transforms it into the y, which is your targeted variable. Okay, so this is a simple perceptron that we know. It is a single layer, you can say. Then we have already seen there can be many neurons in a layer. So this is in this diagram we are showing a one layer where 4 neurons are there, and input parameters are m number of parameters are there from x1 to xm, and they are fed to these neurons in all possible combinations, right? And same way again here, the activation function is transforming the input to the output, and we are getting the targeted variables in the form of the y1 to yn. So here we are having the number of n number of classes because we are taking output variables y1 to yn. So any one of them may be high, giving the information or the prediction that that particular class is valid and all other are invalid. Now, when we talk about the sequential data, we are having the input data, time-dependent input data that we can call as xt. Right, and that data is fed to our neuron or the neural network, and we get a output data or the targeted data variable y cap t. Okay, so that is a predicted y at the time of t. Right. So when now we are coming to the sequential modeling of the neural networks. We can represent the same information just by rotating to the vertical plane. So we are having some input vector xt in the form of xt0, xt1, xt2, xt3, and so on, and it is fed to the neural network, and we get the output vector y cap t, which is the target variable. Okay, so this is time dependent, which is shown by the subscript t. So we can have so many instances of similar type during various instances of the time. Okay, so these we can call as the individual time steps. Individual time steps, like we are having input vector in the form of x0, x1, x2 at the different time steps, and they are fed to the neural network, and they give the target variable values y0 cap, y1 cap, and y2 cap, and so on. Okay, but here something is missing. What is missing? That because these neurons are shown here independent of each other, that should not be there, because there is a sequence. So sequences follow each other. That is, the next in the sequence would be dependent upon the previous one. So there should shown some dependency should be shown among these time steps, which is missing in this diagram. So that dependency we have to show in some form. That we are showing through a hidden variable h0. It means that the neuron at the time stamp x0, time step 0, it is feedbacking, or it is feeding forward its information to the next sequence neuron in the form of this h0, which is the hidden variable, which is transforming the information, its information, or its, you can say, its context to the next neuron. Same way, we are transferring these h0, h1, h2 to the next time steps for the neuron. Okay, so this way we have to show the dependency. It means that the any targeted output variable value does not only depend upon x1, like y1 cap does not only depend upon x1, but also it depends upon the previous state's hidden history, that is that in the form of h0. It means that y1 cap depends at the same time over x1, as well as it depends upon the h0. Similarly, y2 cap, it depends upon the present input state, that is the x2, as well as the previous state's hidden data, that is the h1. So this way we are showing some sort of recurrence between the various time steps. That is a feature in RNN. So RNN, you can say, is based on this recurrence. There should be some dependencies between the time steps of the neuron. So this dependency we can show in this form, that is the output y cap t at time t, it depends, it is a function of xt, that is the present input value xt, comma ht minus 1, the history data or the hidden data from the previous state. So it depends upon, so output depends upon the input of that time step, as well as the past memory. So ht minus 1 represents the past memory for that particular time step. Right. So this, we can say that there is a sort of recurrence relationship. This is why we call it as RNN. The same we can show in a compact form, which is represented on the left side. You can see on the left side, we are having one input vector xt in the form of t0, t1, t2 up to tn, and there is a recurrent cell in which ht is being feedback, or the repeatedly feeded in the form of the ht, that is the hidden variable value, which is giving the history data or the past memory data. So basically, and this y cap t depends upon both xt and as well as the ht, that is the output vector. Okay, so we can say that in recurrent neural network or RNN, the cell or the you can say the neural network is having some memory element also, because then only you would be able to restore this memory variable of the past history ht retained within it. So it contains some sort of memory mechanism also. Okay, so this way we can say that xt is transforming yt with the help of the previous history data ht. Okay, so past memories. So if we unwrap this, then the right side neural network model we get, and the compact form we represent on the left side. So we come to the recurrent neural networks or RNN. Right. So RNNs are a tool for analyzing sequential data. They are distinct from feed-forward networks. They allow cycles in computational graphs, delayed feedback from an early step in computation. They allow an internal state or memory. Inputs received at earlier time step affects RNN's response to the current input. RNN follows a Markov assumption. The hidden state HT of the network captures the information from all the previous inputs. That is, we can update HT. How we can update HT? With the help of the function which is dependent of the weight from HT minus 1 comma XT. So the new the HT of the current state will be the function of the previous state HT, previous HT minus 1, and the present XT, that is the input. Okay, so this way we can update the HT. So we are having this RNNs have state HT that is updated at each time step as sequential process. So we have to update this HT every time with the help of this update rule. HT equal to FW of HT minus 1 comma XT. So this HT is updated with the help of the present state as well as the previous HT minus 1. Okay, so this way we have to update this HT in each step, time step. So this is the recurrence relationship. The new cell state HT or the hidden state equal to function of weight for XT, that is the current input vector, comma old state HT minus 1. Right. Now there are so many you can say time steps like here this. So for all these weights are same. For all the states weights we keep the same weight. So that is one important issue. We reuse the same weight matrix at every time step. Right. So the same function and set of the parameters are used at every time step. So it is not that for every time step we use different function and different weights and time step. No, we use the same functions. You can see here in the unwrapped form that same between input and the cell, we are having the weight WXH that is common for all the neurons at that particular time step. So WXH is the weight between input and the hidden state, and that is same. Similarly, WHH we represent the state between the two neurons, that is the previous history and the current history. That weight we give as W, because we have to modify these weights in order to optimize it. Okay, so we make use of these weight parameters for so three types of weight parameters are there. One weight parameter is between the input and the hidden variable, that is called as WXH. The second one is between the one neuron to the other neuron, that is in a internal state, that is a WHH. And the third one is the between the hidden state and the output variable, that is known as the WHY. So these three types of weights we make use, and the weights are same for each time step. We do not make differentiation. The same weights are used in different time steps, every time step. So our output vector will be, so we are having this input vector xt, this hidden state as ht, that is holding the previous history also, and this is output vector y cap t. So output vector y cap t will be equal to w transpose of hy into ht. Okay, w transpose that is of hy means this hy weight into ht. So this is based on these two. So y cap t is computed with in this way. And how do we update the hidden state? As we have seen previously, we make use of the 10h function. We make use of the 10h function. So the new ht will be 10h of whh transpose into ht minus 1 plus wxh transpose into xt. Okay, so this is between, this weight is between hidden state, previous state to next state, and this is related to the current state. So both the components are there which are responsible for updating the ht. One is the weight between the previous state and the current state, and this is the weight that is between the in the current state, current input state vector xt. So this way we can update the hidden state at any time with the help of this update rule, and every time step we have to make use it to get the new ht value. We can see the implementation. We can have a glance of implementation of RNN. So we can make use of the TensorFlow for RNN, for implementation of RNN. So we can see this. We have to TensorFlow.keras.layer, and we first initialize all these parameters, 3 types of weights like xh, hh, and hy. We initialize these parameters. Then we initialize hidden state to zeros, all the hidden states to zeros. Then we update the hidden state. This is the rule for the hidden state update. So we have applied this here 10h formula, and then we compute the output and we return the output. So this way we can implement RNN in TensorFlow. So TensorFlow already gives a built-in method for implementing RNN. This is tf.keras.layers.simplerNN run unit. So this way we can implement very easily in the TensorFlow. Right. So as we already saw the various categories of the sequence modeling. Like we had seen 1-to-1 type of mapping between input and output, that is the binary classification. Many-to-one in the sentiment analysis of some tweet. One-to-many in the image caption or text generation, and many-to-many in the translation and the forecasting. Now, let us come to some issues that arise during the sequential modeling. That are the design criteria. So we shall next discuss with the various issues that are there in the sequential modeling. So to model sequences, we need to handle, so these 4 conditions should be met. That is, first is it should be able to handle variable length sequences. That is not only fixed length sequences, your input can be of any size in time frame, right? So because it is a sequence, so it can be variable length sequence. So that should be ensured. Second is track long-term dependencies. Okay, because sometimes it may be possible that when you talk about the long-term dependencies, it may not be able to correctly relate. So that should not be there. It should be able to track long-term dependencies. Third is it should be able to maintain information about the order. And fourth is it should be able to share parameters across the sequence. Right. So recurrent neural networks or RNN meets these sequence modeling design criteria. All the 4 sequence modeling criteria are fulfilled by the RNN. So we shall see these in details. Right. Like, for example, let us talk about a sequence modeling problem for predicting the next word. Suppose you're having a sentence that is incompletely given, that this morning I took my cat for. Only this much is given. And you have to predict what would be the next word, right? So next word, like here we are predicting the next word is a walk, right? So your input is this morning I took my cat for. So this is the input sequence. This morning I took my cat for. So this is the input sequence that will be inputted, that should be inputted to the your network, neural network. And this is the output. This is the targeted. So this or something similar should be outputted in the target. But the problem is that in neural network, you cannot input the words or text. Neural network cannot interpret words. Okay, so how should we input this information to the neural network? Obviously, we should make some sort of encoding. We should perform some sort of encoding for inputting this information to the neural network. So because neural networks works only on the numerical data, right? Not on the text data. So obviously we should map this text information in the numerical form somehow. So how we can map this? That is known as the encoding language for the neural networks, because neural networks cannot interpret words. So neural networks requires numerical inputs. So the first approach is that is known as embedding. Embedding means transform indexes into a vector of fixed size. Like for example, this is one approach, that is the vocabulary. You make a vocabulary for your corpus of words and you give indexes to each of the word. Like we have given index 1 to A and 2 to cat and so on, and n to walk. Now we are having indexes fixed for each word, and now we can represent any word. Like if we want to represent cat, we can say enable that particular index to 1 and all other indexes to 0 for that value, right? So here it is because the second cat is having the index 2, so we have put 1 on the second index, so it is representing cat. If we want to say represent A, then we would have put 1 in the first index, that is 0th index, so that would be representing A, and so on. So this way we can have, this is known as a one-shot embedding, right? Where we are having these vocabulary is limited, then it may be very suitable, but when vocabulary is large, then it becomes difficult to handle. So the other approach is learned embedding. Learned embedding is a more informed type of encoding, where we can have a sort of geometrical system for representing the words in Cartesian type of system, and the words are represented in some Cartesian form and or numerical form, and those words which are related, they are having less distance than those which are unrelated. Like for example, here dog and cat are related, so they are near to each other, whereas they are far distant from the day, sun, all that, right? So comparatively they are nearer to the happy or sad, right? So this way we can have the embedding of the words with the help of the learned embedding type of system. So we have to, this is the first requirement for making use of the neural network, that we have to make some sort of encoding to feed input the text into the neural network. So the first requirement was that should be fulfilled was to handle the variable sequence length. Like for example, if your text is, or your sentence is the food was great, or Another statement was we visited a restaurant for lunch, or even bigger statement may be there. We were hungry, but cleaned the house before eating. So they are variable length. Any length input is expected. So your model should be able to handle the variable sequence length. Then second is the model long-term dependencies. That is important. Like for example, let us see this example. France is where I grew up, comma, but I now live in Boston, full stop. I speak fluent dash. Now, if you want to predict what is the word here, so you have to think dependencies up till France, up till the very initial, because I grew up in France. Now I live in Boston. So what I speak fluently, whether French or the other language, so that depends. So there is a long-term dependency in this sentence. So that should be fulfilled. So we need information from the distant past also to accurately predict the corrected word. Okay. So this is another issue. The third issue is capture differences in sequence order. Like for example, if there is some change in the sequence of order, then it should be able to identify it. That is, the food was great, comma, not bad at all, versus the food was bad, comma, not good at all. So all the words are same, only difference is in the sequences. So this sequence does matter. So that should be ensured by the model. So these four design criteria should be fulfilled, and RNN fulfills these design criteria. Okay. Next, let us come to back propagation to time. Because what is back propagation? Because you know that in feed forward network also, neural networks, you transform the values of input parameters to the output parameter with the help of some transformation function or like the activation function, right? And this way you go layer by layer up till the end. So in doing there, because when we come to the end at the y, where the targeted variable are there you are having two values. One is the predicted value that you have brought forward from the input to output through the sum function, and the other is the value of the example that is already available with you, the actual value. So the difference between the two is actually the error. So that error should be corrected through the correction in the weights, so that we back propagate through this error, and we assign that error correction to each weight, so that the weights are corrected and our model becomes nearer to the perfection. Okay, so this way it is a sort of iterative process which does carry on. So this is the back propagation algorithm that we make use of. So that is in the feed forward model. Now how we make use of the back propagation or the error correction in case of the RNN. So that is known as the back propagation through time, BPTT, back propagation through time. So how it is done? So you can see that we are having input variables x0, x1, x2, and x3, and we get, with the help of these input variables as well as the previous history data, we get the y, that is the target variable prediction value. Now we are having the actual values also from the example data set, right? So the difference between the actual data and the actual value of y and the predicted value, that is the y cap, we get the loss value. So these are the loss values L0, L1, L2, L3 at different time steps, and we combine these losses to form a loss, overall loss, right? That is overall loss, and that loss should be transferred back to these weights, to update these weights, so that our model is trained, right? So this way we get this L, or the overall loss function, and then we propagate this loss value back to our models various time steps, and finally to the up till the end, up till the first one, so that these weights are updated. Okay, these weights are updated, and thus the error will be iteratively reduced. So this is back propagation through time, which is applicable for the RNNs. So in RNNs, we make use of like this, right? So now this back propagation creates or generates some issues, some problems that we have to discuss. What problems it may generate? There are two types of problems. One is the exploding gradients. One is the exploding gradients and other is the vanishing gradients. So these two issues are there. Exploding gradients are those gradients. Computing the gradient with respect to S0 involves many factors of WHH plus repeated gradient computation. So this way, if when your weight values are greater than 1, your combining of these weights, that you are combining the error from step to step, this may explode the gradient. And the gradient size would be too big. Okay, so that is the problem related to the exploding gradients. Okay, that should not be there. And the second problem is when this values are less than 1, then multiplying the various parameters of the loss function, it would be further reduced. So computing the gradient with respect to S0 involves many factors of WHS plus repeated gradient computation. So by this repeated gradient computation, if the values are less than 1, then it will be further reduced, because if you multiply to fraction numbers, then it will be even lesser. So it will be lesser. So this will ultimately, it will be vanishing gradient. It means that the effect of the change would not reach to the far distances due to vanishing gradients. Okay, so vanishing gradients are also undesirable, and exploding gradients are also undesirable. So both these two issues are there in the gradient flow. Okay, so the problem of long-term dependencies. Now let us come to the problem of the long-term dependencies. So why vanishing gradient is a problem? Because when there is a issue of the vanishing gradient, so our model will not be able to handle the long-term dependencies, because going the long-term time steps, and the parameters would be reduced further and further, and it will be vanishing and will be near to 0. So obviously it will not be carrying the information, right? So this is why when you multiply very small numbers together, the error due to further back, so that is one issue. Then error due to further back time steps have smaller and smaller gradients, and bias parameters to capture short-term dependencies, right? So these are the issues. Like for example, when long-term dependencies are there, that is Y3 not only depends upon X3, but its distant parameters, past parameters like X0 and X1, like the clouds are in the dash. So this is why this depends upon the clouds. Okay, so the same way I grew up in the farm, France, and I speak fluently. So this Y cap T, this depends upon X0 and X1. So these are far distant. So diminishing gradient, vanishing gradient is a problem in these cases. That should not be there. So what is the trick to avoid this diminishing gradient? So first trick is the use proper activation function, appropriate activation function. So normally we make use of the sigmoidal function. You see, this is the sigmoidal function, blue color, right? We can have one 10h derivative, which is this one, and we are also having a ReLU function, right? So ReLU function, that is the rectified linear unit. ReLU function, it maps input values to the maximum of 0 and the input values. So introducing sparsely and reducing the likelihood of the vanishing gradients, right? So using the ReLU function prevents f dash from shrinking the gradient when x is greater than 0. Okay, so this is a useful function, activation function ReLU, which can help you prevent the vanishing gradient. The second trick is parameter initialization. So we can initialize weights to the identity matrix IN, that is an identity matrix, and initialize the biases to 0. Okay, so weights can be initialized in this identity matrix form and biases are initialized to 0. This helps prevent the weights from shrinking to 0. So this is another approach for vanishing gradient problem. And next, third important trick is gated cells. Gated cells, they use gates to selectively add or remove information within each recurrent unit, right? So the gated cells implies that you are having some sort of gated cells which prevent or forward some information to the next cell. Okay, so they optionally let the information through the cell. Means information can be stopped as well as can be forwarded. So this approach is implemented in LSTM, or the long short-term memory networks, that rely on the gated cell to track information throughout many time steps. What will be the benefit? Because in the gated cell, you ultimately filter in the hidden cell or the gated cell, you pass only the required information and stop the unnecessary information to move. So this will reduce the issue related to the vanishing gradient. So this is very important approach which has been implemented in long short-term memory, or LSTM, which is an important you can say variant in the RNN of the RNN. Okay, so this is one trick which is very much useful, long short-term memory. So this can be useful, and in fact I should give you the idea that one of my PhD scholars has made use of this LSTM for keystroke dynamics based biometric authentication using deep learning. Okay, so this is using the LSTM. Basically, I will shortly discuss this issue of this topic, that is keystroke dynamics based, because in biometric for biometric authentication, what normally we do, we make use of the camera or the thumb impression or like that, okay, for identifying a person. But you talk about say a case where you are making use of the online examination, online proctored examination, right? So in that case, the authentication, one-time authentication may not be suitable, because the login password one person is entering, and then after successful logging and into the system, on the other time stamp, the person may exchange from the other person, which is not the authentic person. So this is why we want a sort of continuous authentication of the person who is appearing in the online examination, proctored examination. So for that, keystroke dynamics has been used here. Keystroke dynamics means the person is making use of the computer's key for typing. So the behavior of his typing pattern, what is the behavior of his typing, so that determines the authentication of that person. So continuously your model or your system is authenticating the person based on his keystroke behavior, that on what pace, at what pace he is typing the keys. So obviously this is a time dependent issue, or this is a sequential issue. So it would be suitable for making use of the RNN to handle this type of data. So this this PhD thesis has made use of the keystroke dynamics based on the LSTM, right? So this has made use of LSTM, long short-term memory. right? So we shall talk about some basics of LSTM, long short-term memory, key concepts. They maintain a cell state, use gates to control the flow of information, control the flow of information. So what are these tools for controlling the flow? Forget gates gets rid of the irrelevant information. So some sort of gates are the forget gates. Store relevant information from the current input. So right, so there are some gates that are forget type, and there are some gates which are the store type. And we selectively update the cell state. And output gates return a filtered version of the cell state. So back propagation is made through time, BPTT, with partially uninterrupted gradient flow. Right. So it is not fully uninterrupted, but it is partially uninterrupted because we filter the unnecessary information so that the vanishing gradient problem is removed. Okay, now RNN applications and limitations. We come to the RNN applications and limitations. We have already discussed a few applications. Like here we are having one application named music generation. Right, so input is the sheet music, and the output is the next character in the sheet music. Right, so this way, this is many to many type of task which makes use of the RNN. Okay, then sentiment classification, we have already discussed that sequence of words are given and you have to give the tweet sentiment. Now, there are certain limitations of this recurrent models or the RNNs. What are these limitations? First, because essentially RNNs are sequential in nature because they follow the recurrence relation. The information is flowing sequentially only. So obviously there is a encoding bottleneck, right? So it is time taking. So it may not be very suitable for the real-time applications because of this bottleneck of the sequential, because you have to encode the information sequentially only. So because there is no parallelization, so it is slow in nature, and then it is not long memory. It is not time because due to vanishing gradient problems, you are having a limitation that how long you can connect with the back or the history. So that is the issue. So these are the limitations of the RNN. Okay, so RNN, because in RNN we can say that these are the cells where sequential, so some sort of parallelism, if they can be brought in these hidden states in the form of these hidden data, then we can improve this encoding bottleneck. Okay, so how we are having certain sequence of inputs like x0, x1 up till xt, that is input. We are having some sequence of features. Okay, that is the feature vector, and we are having sequence of outputs like y cap 0 up till yt, that is the output. So these were not till now, these are sequential in nature, sequence by sequence. It is sequence by sequence. This is why it is having a sort of bottleneck. So what we can do, we can have some sort of parallelism. Instead of the sequence by sequence, we can have a global feature vector. We can have a global feature vector which may be containing all the input, all the hidden state values, all the hidden, and it is this whole as a whole. This is responsible for transforming x to y in the time frame because it is a sequential data. So it considers all the cells information for transforming the input to output. So this, you can say, some sort of parallelism we are bringing through this feature vector. So here comes the concept of attention. Attention does solve our problem because attention, we will be attending only those cells which are more important, not all the cells, which gives you the context, we shall attend those cells, and that is the concept of the attention. Okay, so what is the intuition behind the self-attention? Attending to the most important parts of an input. Attending to the most important part of the input. Suppose this is an image of this Iron Man, and if we want to find the most important part of this image, we can have two approaches. One approach is to scan this whole image sequentially, pixel by pixel. Okay, so this is sequential, sequence by sequence nature. And another approach is the like a search problem. It is a search problem. Identify which parts to attend to and extract the features with the high attention. So we have identified the portion which is having high attention, and we remove the other. So this is a sort of search problem. So attending to the most important parts of an input, that is the attention. Right. So when you let us take another example of attention with search. When we make a search over some search engine like YouTube or Google. Suppose in YouTube we want to search the video for deep learning. Okay. So this deep learning we want to search. This we call as query. So our query or queue is deep learning. Okay. And when we search, we are having so many options that come. These all our options have come as a result of searching this query. So these we call as key, right? So key means K1, K2, K3. These are the keys, right? So now which particular key is giving attention over the particular deep learning, that we have to see. So and eliminate all the others. Like this particular key K2 is more appropriate. So attention is made over this through search, and the all other two are eliminated, right? So how we computed this search, how we made search? We made search bit how is the similar? What is the similarity between the key and a queue? That is, how similar is the key to the queue? Right. So we compute the attention mask. How similar is each key to the desired query? Okay. Second is step is extract the values based on the attention. We extract the value, return the value of the highest attention. Okay. Like, for example, learning self-attention with the neural network, goal is to identify and attend to the most important features in the input. Right, he tossed the tennis ball to serve. So you are having this embedding. The first is encode the position information, because you have to, although you are now making use of a matrix for all the hidden information, but still you must have the position information among the various cells. Right, that is what is the position. So this is a position aware encoding, right? So even if you are now not processing sequence by sequence, but at the same time you must have the position information, so that you are able to fulfill all the four design criteria. You must preserve somewhere this position information, right? So data is fed. And what is the difference between the previous LSTM approach and this? In the previous LSTM, data is fed step by step or the sequence by sequence, but here the data is fed all at once. But still, it needs to encode the position information to understand the order. So we make the encoding, which is the position aware encoding, right? So this encoding, this particular text, you can say these words these are not words, but we call these as the cells. These cells are embedded with this position information like P0, P1, P6, and they are encoded into the position aware encoding in green, shown in the green. So now they know the green cells, they know their relative positions. Although they are in the same home, they are in the same matrix, but they know their relative positions, or they are aware of their positions. Okay, so that is important. Now we are having query queue, right? We have encoded the position information into these green cells. Okay, position embedding. Now we are having it's three instances of the same, right? For query, key, and values, right? Query means what is to be searched, key is the options, and value is the value which is actually the value. Okay, so we extract the query, key, and value for the search. So position embedding then into linear layer equal to output. So this is the approach for all the three, query, key, and value. If you recall, in the classical AI, like in Prolog, you are having these three types of you can say predicates, right? One is the query, other is the key or or the rules, and third one is the fact. So some same way we can see here these three types of things. Now, how do we learn self-attention with neural networks? So we compute because we shall compare between the key and the query, and we find the similarity index. So how we find the similarity index? We compute the attention weight. That similarity index is, you can call as attention weight. So we can treat them as vectors, two vectors, query q and key k, and we find the dot product or the projection of q over the k. So that is the scaling. So that is the similarity matrix, q into k transpose. So this is known as a cosine similarity. So this will give the attention score. So this is similarity matrix, and we can identify. Suppose you want to show it graphically also attention. So on the say row side we are taking query, and on the column side we are taking the other thing, that is the key. Then you can see the color of these cells, which is exactly matching, which is the higher darkest in nature, and as they are far in relationship, they are lighter in nature. So this way we can say. So how we can find the attention weight? Attention weight equal to q into k transpose, and that is the cosine similarity. Upon scaling, we scale that and we find the softmax function, which brings that in the value between 0 and 1. So that is known as the attention weight. So this way we find the attention weight, which so what is the step? Encode the position information, extract the query, key, and value for the search, compute the attention weight, extract the features with high attention. Okay, now last step is self-attention to extract the features. Okay, so this is done through the softmax of q into k transpose upon scaling into v, into value. Value means that whatever is your example data, which is the actual value. You multiply with that, and you get the attention matrix A for q, v, k, and v. Query, this k, key, and value. So it depends upon these three things. So this we can show through the neural network. You are having three position encoded data. One is the query, other is the key, and third is the value. You find the similarity between the query and q through this metric multiplication, that you find cosine similarity, then you scale it, then softmax it, that is bring between 0 and 1. Then you get the value, multiply with this softmax value and this matrix, and this way you get the output. And this output gives you the most attention value. Okay, so this way attention is the foundation building block of the transformer architecture. Basically this attention mechanism, because what is the benefit of this attention? That you can create large language models, like where that very distant similarities are there, and that we see in the form of the chat GPT and all that, which brings the context to our queries, right? And based on the context, it gives us the perfect solution, tries to give the perfect solution. So attention is the foundation building block of the transformer architecture. So this, you can say, is a key element or the unit of the transformer architecture, which is responsible, which is a key gradient of the large language model, or like chat GPT, etc. Okay, so applying multiple self-attention heads. So we are having the attention weight, that we compute, and we are having the actual value by which we get the output. Okay, and we are having several attention heads, so which can give you several outputs. Like this is output from attention head 1, which gives you which focuses or which gives attention over this Iron Man. The second attention head gives you focus on this building. Okay, the third attention head gives you the focus over this you can say flying object. Okay, so this way different attention heads can give the different outputs. Okay, so that is the large language model concept and generative AI. So LLMs are a class of deep learning models designed to process and understand vast amount of natural language data. LLMs are called large because they are pre-trained with a large number of parameters, that is 100 million plus, on large corp of text, that is a pre-trained, to process or understand and generate the natural language text for a wide variety of NLP tasks. LLMs are built on the neural network architectures, particularly transformer architecture, which allows them to capture complex language patterns and relationships between words or phrases in large scale text data sets. So, all these applications are sequential in nature, because when you talk about the text processing, there is sequence, right? So you have to apply this sequential modeling. So the latest in the sequential modeling is the attention mechanism, which is implemented in the large language models, we can say. The transformer architecture relies on attention mechanism such as self-attention and multi-head attention, which allows the model to understand the relationship between the words in a text by weighing the importance of different words or phrases in a given text. So the LLM family includes BERT, GPT, OpenAI's model, EALM, LIAMA2, and all that. So we are having two types of generative AI here. One is the discriminative model and other is the generative model. Discriminative model, which is used to classify the existing data points, like for example, images of the cats and pigs in the difference, it mostly belongs to the supervised machine learning task. And generative model tries to understand the data set structure and generate similar examples. So it mostly belongs to the unsupervised and semi-supervised machine learning task. Okay, so basically, like for example, the descriptive model, you can talk about the chat GPT, right? Where you try to find some information and it with your AI model gives you the very precise information by applying the context over all the information available. Okay, so that is a discriminative model. Generative models, you can see that you can generate new things from the existing, right? Like for example, you can create new images or based on your queries and all that, right? So that is the generative model. So generative algorithms do complete opposite. Instead of predicting a label from the features, they do opposite. That is, they try to predict the feature given a label. So discriminative algorithms care about the relationship between X and Y, generating model about how you and therefore meaning by tracking the relationship in sequential data like words in the sentence. That is why this technology often used in NLP tasks. Right, so some of the most examples are GPT-3 and Lambda. Right, so it makes use of encoders and decoders, transformer. Right, transformer is the building block, so which makes use of the encoder. Encoder works on the input sequence. It extracts all the features from the sequence, converts them into the vectors, and then passes them to the decoder. And decoder works on the large output sequence. Each decoder receives encoder layer output, derives context from them, and generates the output sequence. Okay, so transformer models use the attention or self-attention mechanism. So these are applied over various contexts in various applications like language processing, biological sequences, computer vision. So self-attention is applied here, and you can say the results are very good, and in the real time you can process, because it is not sequential in nature, right? It is having certain parallelism. So we can discuss the summary of this discussion. Like RNNs are well suited for sequential modeling tasks. Then model sequences by a recurrence relationship, because in RNN there is sequence to sequence, so there is a recurrence relationship among various time steps. Then training RNN with back propagation through time. Then we saw the models for music generation, classification, machine translation, and more. Then self-attention to model sequence without recurrence. So self-attention is very important mechanism, and self-attention is the basis for many large language models. Right. So that's all. So these are the acknowledgements, and thank you.
Thank you, sir. It is requested to all the participants, please unmute your mic and ask any query. Sir, I think there is no question.
Okay, thank you very much for
Thank you, sir.
attending and listening me, and I hope that this will be useful for all. Thank you very much.
Thank you so much, sir, for sharing your valuable insights with us in the final session of your FDP. Your experience and expertise have added great value to our program. To all your participants, thank you for your active participation and patience over the past week. Thank you so much, sir. Now, I would like to invite Mr. Santanu Sukla, sir, to proceed with the valedictory session. Thank you, sir.
Thank you, sir. It was a
Thank you very much, Vibhasji.
nice session, sir. Actually, we'll wait for next 10 minutes. Actually, director sir is on the way. So once he comes, then we'll start the valedictory function.
Okay, sure. Okay.
Request to you that please give your valuable time for valedictory session also. So still, if any have any doubt, he or she can ask the queries. Even any faculty member who have any query related with his doctorate or something like suggestion with sir, he can directly ask at this platform.
Good afternoon, sir. Sir, one question from my side.
Yes, please, Shraddha.
Sir, give me some suggestions or tips for how to write research paper.
Okay, so are you pursuing PhD at present?
No, sir.
You are in BTech or MTech or PhD?
Sir, I'm MTech.
You are in.
Rajkot Engineering College.
Okay. So for research paper, the first thing is you have to go through various literature, okay, and collect the state of art, that is the past 5 to 6 years at least, papers through all the possible journals that are important, like Springer or Elsevier or IEEE ACM, and other also like Trailer and Francis, where you are able to find out. Then you have to first read, not through thoroughly, but just go through the abstract and find the similarity, that how it is similar to your task. So you shortlist those papers which are more nearer to your task. Once you shortlist 3 or 4 papers, you have to make a base paper. What is the base paper? What should be the base paper for your work, which you are going to implement? So you have to see the implementational aspects also, the what data sets they have used, from what sources they have used, right? And whether they have given some implementation directions or some ideas. So you have to see that. Then what you have to implement it, first it's at the first iteration, you should make you can say the first prototype for the work, okay, whatever is the task that you have to make. And once you have made the prototype, then you have to make enhancement over it. So your approach should be that whatever is the whatever are the results in that paper they are showing, you should make some enhancements, maybe through the methodology or in some approaches, right? So you make certain some enhancements, and if you are able to show or compare the results through their methodology and through your methodology, improved methodology, then it is the best type of work that is suggested, that you have made some enhancement over it. Okay, so you should go incrementally during the research only. You should not think in vague form that anything you go without any basis. So there should be some proper basis. You should think only in terms of making some incremental change over that basis, not a complete altogether different that may not be you can say feasible that you find at the next end. In this stage, you should only think in terms of making a small change. Okay, that does matter, right? So that should be there.
Okay, sir. Thank you. Okay, sir. Thank you, sir.
Welcome.
अभिषेक क्विज शेयर कर दिया आपने? शेयर कर दो अभी
सर।
इसी पे
लास्ट ऑफ वैलिडिटी सेशन होगा सर।
हाँ नहीं शेयर कर दो, क्विज तो शेयर ही कर दो पैरेलली।
ओके सर,
ग्रुप पे ही शेयर कर दो। पार्टिसिपेंट से रिक्वेस्ट रहेगी कि वी विल ट्राई टू डिलीवर द सर्टिफिकेट्स विद इन 2 weeks after the processing. So keep patience, and definitely within next 3 working days we will share the attendance, and on the basis of that attendance only we will issue the certificates. So if you have any doubt related with your attendance, then only we will that means entertain the query. Otherwise, it will be quite difficult for us to reply each and every query on the group. So I think that in next 3 working days we will share the attendance, and after that, taking permissions from the authorities, we will share the certificates. So Director sir has joined with us. Now I would like to request Shantanu to start for the valedictory session. Thank you so much, sir. As our meaningful journey through this week-long faculty development program, I would like to take a moment to express our sincere gratitude for your active participation, dedication, and patience throughout this academic journey. It has indeed been a valuable experience filled with learning, interaction, and growth. We have now arrived at the final segment of our FDP. To begin this validatory session, I would like to invite a few of our participants to kindly share their reflection and experience from this program. I will now call upon some of our participants by name. So please, I have called the name and you can unmute your mic and share the experience in 5 days. Okay, so first name is Dr. Sumit Babu. Please unmute your mic and share your thoughts about the FDP. Dr. Sumit Babu.
Good afternoon, sir.
Good afternoon.
Hello.
Good afternoon. Yes, please share your thoughts, sir.
Sir, thanks for this training. This is very valuable training from the starting of the lecture. The first lecture is very informative, conducted by Professor Raghuraj Singh sir, and all the sessions such as Dr. Satyaprakash sir, Dr. R.S. Yadav sir, and other conveyor are conducted very valuable information to all the participants. And thanks to REC Banda and HOD, Dr. Vivas sir, for providing this FDP. Thank you.
Okay, thank you, Sumit sir. Thank you very much. Now, next participants, Dr. Shivangi Avasthi. Dr. Shivangi Avasthi, please unmute your mic. Next one. Okay, so next participants, Dr. Vinay Yadav, unmute your mic and also camera. Dr. Vinay Yadav. Okay, Mr. Shishir Ranjan. Mr. Shishir Ranjan. Okay, next participant, Dr. Richa Vijay. If you are available, please unmute your mic and camera. Dr. Richa Vijay. Okay, next, Mr. N. Rajesh. Mr. N. Rajesh.
Yeah,
Yeah, please unmute your mic and camera also and share your thoughts about the FDP.
yeah, I would like to thank the organizers for giving the opportunity for attending this. So all the sessions were very interactive and very informative. So thank you very much for doing that. Thank you.
Okay, thank you so much, sir. Next participants, Ms. Rajni Sharma. Ms. Rajni Sharma. Okay, next participants, Ms. Poonam Yadav. Ms. Poonam Yadav. Okay, next participants, Ms. Vaishali Gupta. Ms. Vaishali Gupta. Okay, next participants, Dr. Siddharth Shankar Vishwas. Dr. Siddharth Shankar Vishwas. Okay, next participant, Dr. Shalini Gupta. Dr. Shalini Gupta. Okay, next participants, Dr. Shubha Jain. Dr. Shubha Jain. Okay, next participant, Mr. Deep Kumar Srivastava. Anyone other who wants to share experience? Any other participants? Okay. Thank you all the participants for your kind words and constructive feedback. Your reflection truly highlight the impact and effectiveness of this program. Now it's my privilege to invite the head of department and convener of this FDP, Dr. Vibhash Yadav sir, to present an overview of the entire journey of this faculty development program. So, sir, please.
Thank you. Good afternoon, everyone. It gives me immense pleasure to stand before you today on the occasion of this valedictory session of our faculty development program. Over last 5 days, we have had the privilege of engaging in insightful discussions, enriching sessions, and meaningful collaborations that have not only expanded our knowledge, but also invigorated our passion for teaching and learning. As we draw the curtains of our faculty development program on advanced AI development and research challenges, I am filled with a sense of accomplishment and gratitude. Over the past days, we have embarked on an enlightening journey exploring the multifaceted world of artificial intelligence, its advancements, and the challenges that lie ahead in research and development. Our session has delved deep into the realms of machine learning, deep learning, natural language processing, and other sub-branches of artificial intelligence and the ethical considerations that accompany AI innovations. We have examined real-world applications from healthcare diagnostics to sustainable development and discussed the transformative impact of AI across various sectors. The insights shared by our esteemed speakers have not only broadened our understanding, but have also ignited a passion for continued exploration in the dynamic field. This program has underscored the importance of interdisciplinary collaboration, critical thinking, and continuous learning. As educators and researchers, definitely we are now better equipped to integrate AI concepts in our curriculum, foster innovative research, and definitely to guide our students in navigating the complexities of digital age. As the outset of this program, I would like to express my heartfelt gratitude to our Honorable Vice Chancellor, sir, respected Director, sir, for his continuous support and motivation. Definitely esteemed resource persons and speakers who have graciously shared their time, expertise, and experiences with us. Sir, your contribution have been invaluable and your perspective have truly broadened our academic horizons. I would also like to extend my thanks to the organizing team for their meticulous planning and seamless execution of the program. Behind every successful event, there is a dedicated team working tirelessly to ensure that every detail is perfect, and my team has done this in a great manner. So thank you, team, for your coordination and the way through which you have executed all the things, all the queries of participants, and managed each session in a very remarkable way. To my fellow participants, thank you for your enthusiastic participation, your thoughtful questions, and your collaborative spirit. This program was not just about learning from experts, but also about learning from one another. The diversity of ideas and experiences shared has made this journey all the more enriching. Now we are at the stage to close of the program. So let us carry forward the insights we have gained, implement to innovative strategies we have learned, and continue to strive for excellence in our respective institutions. The true success of this FDP
lies in how we translate knowledge into our actions and inspirations into impact. So let this not to be end, but I think that it is a new beginning and renewed commitment to academic growth, pedagogical innovations, and professional excellence. Once again, I would like to thank you all for making this program memorable. Wishing you all continued success in your academic and professional journeys. And again, I would like to give my sincere gratitude to speakers, our respected director sir, and my colleagues who make who done a remarkable effort to make this event successful. Thank you, everyone.
Thank you very much, sir, for your insightful summary and for leading this initiative with such dedication. Next, I would like to invite one of our esteemed resource person, Professor Prabhat Verma sir, to deliver a few words as concluding remarks. Your valuable insight and contribution have greatly enhanced the quality of this FDP. So, sir, please. Sir, please unmute your mic, sir.
First of all, good afternoon to respected director, sir.
Namaskar, Prabhat.
Sir, namaskar. So it gives me immense pleasure to become part of this valedictory function of 5 days online FDP on advanced AI development and research challenges that conducted between 21st to 25th of April 2025 by Department of Information Technology, REC Banda. So I am very much happy that the team took this lead over this conducting this very relevant and the contemporary topic of the advanced AI developments. And I hope that whatever the participants have got ideas or the concepts from this FDP will be helpful for them in long journey of their academic career. What I have seen from my personal experience, that for any topic to proceed ahead, you have to make beginning somewhere. And how interesting your beginning becomes is that how you were introduced to that particular topic interestingly, and how the curiosity was raised in your mind and heart by someone that is the you can say which is the responsible factor for proceeding ahead in that particular direction. So I have seen that if I have got some good clues by some expert or by some teacher or by some guide, then I have taken that by heart and I proceeded ahead in that particular area. At the same time, when the basics or the beginning was not very good, then I had seen that the end results were not at all satisfactory, and in fact my interest for that particular topic was also diminished. So that is very important, that you have to take one stepping stone and you have to begin with the chosen area or the chosen field that you have and you have to proceed with ahead with it. So I congratulate the whole team, especially Dr. Vibhash Yadav for conducting such a nice FDP. And I hope that in future also similar FDPs will be conducted. And I thank the team for making me part of this team. I have listened to 2 or 3 lectures in this FDP, and I found them very, very, very good and very informative. So my best wishes to all the participants, and I hope that all of us will be leading and will be getting benefited with similar type of activities. So thank you very much, sir. Thank you. Namaskar.
Thank you. Thank you so much, sir, for your kind words and appreciation. Your encouragement means a lot of us. Now, I have the honor of inviting our chief guest and the respected director of Rajki Engineering College, Banda, Professor S.P. Shukla, sir, to kindly address the gathering and bless us with his encouraging words on the successful organization of the FDP.
धन्यवाद शांतनु। वैलिडिटी सेशन में उपस्थित हमारे एक्सपर्ट डॉक्टर प्रभात वर्मा जी, HOD IT इस संस्थान के और डीन एकेडमिक्स और विभागाध्यक्ष और पार्टिसिपेंट्स, हमें आज इस 5 दिन की जो FDP है 21 से 25 तक हमारे संस्थान ने आयोजित की एडवांस AI डेवलपमेंट एंड रिसर्च चैलेंजेस, और इसके सक्सेसफुल समापन पर आज मुझे बहुत ही खुशी हो रही है कि जो भी प्लानिंग की गई थी FDP के लिए कि कहाँ से कौन सा एक्सपर्ट किस सेशन में आएगा और किस टॉपिक पे बोलेगा, तो वो सब बहुत ही मेटिकुलसली हमारी टीम जो थी, जो ऑर्गेनाइजिंग टीम है, उसने इसको संभव किया। और जैसा मुझे बताया गया है कि लगभग 200 पार्टिसिपेंट्स ने इसको या तो डायरेक्टली हमारी गूगल मीट के माध्यम से, लिंक के माध्यम से, या यूट्यूब चैनल के माध्यम से इसको सुना है। और एक बार जब ये यूट्यूब चैनल पे आ गया तो ये क्योंकि रिकॉर्डेड फॉर्म में रहेगा तो भविष्य में भी कोई भी फैकल्टी इसका लाभ उठा पाएगी। तो ये हमारे कॉलेज के लिए बड़ी हर्ष की बात है कि मतलब हमने सीमित संसाधनों में अपने विभाष जी ने अपने प्रयासों से, डॉक्टर विभाष ने अपने प्रयासों से सारे रिसोर्स पर्सन्स को इकट्ठा करके और इस तरह की एक ऑनलाइन FDP कराई। और इसमें जो पार्टिसिपेशन मैंने बताया ज़्यादा संख्या में हुआ, वो इस चीज़ को शो कर रहा है कि कितना आज की डेट में ये बर्निंग टॉपिक है और हर आदमी इसके AI के, मशीन लर्निंग के हर एक पहलू को जानने के लिए उत्सुक है कि कैसे ये भविष्य में हम जा करके इसको उपयोग करेंगे, हमारे हित में होगा या अहित में होगा। बहुत डिबेट चल रही है इसमें, लेकिन हमें तो हमेशा लगता है कि जो होता है हमारे अच्छे के लिए होता है और भविष्य में ये हमारे लिए जरूर उज्जवल संभावनाएं लेके आएगा, जिससे हमारे अधिक से अधिक छात्रों को रोजगार मिलेगा और हमारे देश को भी आगे बढ़ाने में मदद करेगा। हम पहले भी, हमारा देश IT के क्षेत्र में सर्विस प्रोवाइड करता रहता है, चाहे वो हमारे डेवलप्ड कंट्री हो, अमेरिका हो या यूरोप हो या अन्य कंट्री। बहुत सारे हमारे जितने भी मल्टीनेशनल बड़ी बड़ी कंपनियां हैं, उनमें हमारे देश के ही इंजीनियर जो पढ़े हैं वो जा करके लीड करना है उन्हें कंपनीज को। तो हमें ये जरूर है कि अभी हम लोग जरूर स्लो प्रोग्रेस में थोड़ा सा, जैसे उस दिन हमारे माननीय कुलपति जी ने इनॉग्रल में कहा था, लेकिन हमें विश्वास है कि हम स्लो जरूर हैं, लेकिन अंत में खरगोश को हराएंगे हम लोग कछुए की स्पीड से भी चल करके। और अंत में डंका तो भारत देश का ही बजेगा इसमें, क्योंकि हमारे यहाँ जो युवा शक्ति है और जो इस तरह से सीखने की क्षमता रखती है चीज़ों को, वो सीख करके आगे जा करके जरूर हम अपने देश की कंपनियों का ही नहीं बल्कि जो विकसित देश हैं उनकी भी कंपनियों का नेतृत्व करेंगे और भारत इस दिशा में एक अहम रोल निभाएगा। हमें ये भी खुशी है कि डॉक्टर विभाष यादव ने इस FDP के साथ साथ छात्रों का भी यहाँ पे ट्रेनिंग का एक प्रोग्राम कुछ रखा हुआ है आगे, शायद 29 तारीख को। तो जो भी शिक्षक यहाँ से अगर FDP में कुछ लेके जा रहे हैं तो कोशिश करें सभी लोग कि इस नॉलेज को जो हमारे एक्सपर्ट्स के माध्यम से हमें मिला है उसको हम छात्रों तक पहुंचाने की कोशिश करें, और जितना हैंड्स ऑन ट्रेनिंग और इस तरह से करके उनको हम हैंड होल्डिंग कर पाएंगे, वही हमारे भविष्य में काम आएगा। एक बार फिर से इस FDP को ऑर्गेनाइज करने के लिए हम अपनी ऑर्गेनाइजिंग टीम, अपने IT डिपार्टमेंट के हेड डॉक्टर विभाष यादव को बहुत बहुत शुभकामनाएं और बधाई देते हैं। धन्यवाद।
Thank you so much, sir, for your inspiring and appreciative words. We are truly grateful for your presence and support. Now, I would like to invite our respected Registrar of Rajki Engineering College, Banda, Dr. Ashutosh Tiwari, sir, to deliver the vote of thanks and formally close the session. Sir, please.
Thank you, Santanu. Esteemed guests, faculty members, dedicated organizing committee, and enthusiastic participants. As we gather for the validatory session of this enriching 1 week online FDP on advanced AI and research challenges, organized at Rajki Engineering College, Banda, it is with immense gratitude that I stand before you to deliver this vote of thanks on behalf of entire REC Banda family. This journey from the insightful inaugural session to the comprehensive discussions over the past few days have been incredibly illuminating and inspiring. While our experts are not physically present at this moment, their profound knowledge and visionary perspectives have been the cornerstone of this successful program. We extend our deepest appreciation to each of them. First of all, to Professor J.P. Pandey, sir, Honorable Vice Chancellor of Dr. APJ Abdul Kalam Technical University, Lucknow, for gracing our inaugural session and setting a guiding light for our exploration into the future of artificial intelligence. Then to Professor Raghuraj Singh Ji from HBTU Kanpur for demystifying the intricacies of knowledge-based systems. To Professor Sanjay Kumar Singh Ji from the Department of Computer Science and Engineering, IIT BHU Varanasi, for highlighting the transformative power of AI in healthcare. To Professor Devashish Das Ji from the Department of Computer Science and Engineering, IIT Jodhpur, for providing a fascinating vision of generative AI and edge intelligence for intelligent transport systems. To Dr. Rakesh Kumar Ji from Department of Computer Science and Engineering, IIMUT Gorakhpur, for elucidating the crucial role of edge fog and AI in powering the intelligent future of Internet of Things. To Professor R.K. Dwivedi Ji from the Department of Computer Science and Engineering, Tirthankar Mahavir University, Moradabad, for offering a balanced perspective on demystifying AI and its impact on society. To Dr. Satya Prakash Ji from the Department of Computer Science and Engineering Department, IIMUT Gorakhpur, for sharing valuable insights into the Symposium of Demystifying AI Advancement. To Dr. Amod Kumar Tiwari Ji from the Department of Computer Science and Engineering, Rajki Engineering College, Sonbhadra, for his expert analysis of the use of AI in a hybrid environment. To Professor Surya Prakash Ji from the Department of Computer Science and Engineering, IIT Indore, for his in-depth exploration of deep learning for 3D data. To Professor R.S. Yadav Ji from the Department of Computer Science and Engineering, MNIT Prayagraj, for his in-depth exploration of AI in cyber security. And to Professor Prabhat Verma Ji, also present in this meeting, in this validatory session, from the Department of Computer Science and Engineering, HBTU Kanpur, for his in-depth exploration of sequence modeling and LLM. Your expertise has been a guiding force for this FDP, and we are profoundly thankful for your invaluable contributions. We also extend our sincere gratitude to our esteemed Director of Rajki Engineering College, Banda, Professor Shiv Prasad Shukla, sir, whose unwavering support, encouragement, and vision have been instrumental in convincing and realizing this significant program. Sir, your leadership is deeply appreciated. The success of this FDP would not have been possible without the tireless efforts and meticulous planning of our dedicated organizing committee. I would like to express my heartfelt appreciation to, first of all, Dr. Vibhash Yadav Ji, Head of Information Technology Department, REC Banda, our esteemed convener of this FDP also, for his visionary leadership and relentless dedication in orchestrating this entire program. Our efficient co-conveners, Dr. Siddharth Ajaria and Dr. Pushpen Singh Ji, for their meticulous planning and seamless execution. Our dedicated coordinators, Dr. Mohammad Tausif Khan and Mr. Abhijit Singh, for their tireless effort in ensuring the smooth conduction of all sessions and activities. And to the invaluable members of our organizing committee, Dr. Manoj Kumar Singh, Ms. Sonali Pandey, Mr. Abhishek Yadav, Ms. Neha Sankwar, Mr. Indra Kumar Singh, Dr. Anurag Chauhan, Mr. Ankush Rajput, Mr. Shantanu Shukla, Dr. Gyan Singh, Ms. Sadhana Yadav, and Mrs. Nikita Gupta. Your dedication, hard work, and attention to detail have been the backbone for this successful event. Finally, But most importantly, I extend my sincere thanks to all the enthusiastic participants who joined us from across the nation and even beyond. Your active engagement, insightful questions, and keen interest have truly enriched the learning environment and made this FDP a vibrant platform for knowledge exchange. Your participation is the ultimate testament to the success and relevance of this program. This FDP on advanced AI and research challenges has undoubtedly been a significant step towards understanding the future of artificial intelligence and fostering research in this crucial domain. We hope that the knowledge gained and the connections forged during this week will continue to inspire and empower you in your academic and professional endeavors. Thank you to one and all for making this FDP a resounding success. We look forward for future collaborations and continued learning. Jai Hind.
Thank you so much, sir, for your kind words of gratitude and for acknowledging the efforts of everyone involved in making this program a success. So thank you so much, all the participants. Before we conclude, I have one important announcement for all the participants. A quiz has been made available to all the participants and it is mandatory to submit your responses within next 30 minutes. Completion of this quiz is required for the distribution of your participation certificates. The quiz link will be shared in Meet chat box and YouTube link chat box and also in your WhatsApp chat box. So please ensure that submit on time. Thank you. Thank you so much.
Shantanu ji, one thank you is still left. I would also like to thank all the reporters and the print and electronic media for giving us coverage daily for the entire 5 days, and probably the today's coverage will come in tomorrow's newspaper also. Thank you all to them.
Thank you. Thank you so much. Thank you.